So let's continue on 3.5 here, and let's look at this problem here. It says the radius of the circle is 30, find the area of the shaded region. When I'm looking at a problem like this, I think, oh, if I could find the area of my whole circle there, and then I can subtract off the area of the hexagon, and then that would equal the area of the shaded region. So I'm going to go ahead and fill in what I do know. The area of a circle is pi r squared. And they're giving us the radius of that circle, it's 30. So radius is here, 30. Again, I could divide this into triangles here. So that means that's 30 as well. So we already have our radius. It's pi times 30 squared. So we already found the area of the circle. Now let's find the area of the hexagon. To do that, we're going to go ahead and look at one of these triangles right here. I'm just going to pick this one right here. And they're all the same. So if I want to find this angle in there, remember 360 divided by 6 there ends up giving us 60 degrees. So that angle in there is 60 degrees. So I can easily find now the area of one of those triangles is equal to, using the trig area formula, 1/2 AB sine C. So 1/2 30 times 30 times the sine of 60. And I get about 389.7. So now there's 6 of those triangles in there. 1, 2, 3, 4, 5, 6. So to get the area of the hexagon, I can take that one nice area of that triangle and multiply that by 6, and that will give me the area of my hexagon. So 389.7 there times 6. So pi times 30 squared minus 389.7 times 6, and that gives me a total area there of 489.2 for the area of the shaded region. So again, just thought through area of a circle, pi r squared minus the area of a hexagon. We know how to find that. Was going to equal the area of that shaded region. So now let's look at some parallelograms here. As we're looking at our parallelograms, sometimes it helps us to draw out a picture of one of those. It might help us to figure out what we've got for the information and figure out how to do it. So that's what I'm going to do. Parallelogram here looks kind of like that. It says the diagonals are 8 and 14. And it says that they meet at the center here. So this one right here looks an obtuse angle. I'm going to call this one here 40 degrees. So, well, 44 degrees. So an interesting thing about these is if this one's 44, these are supplementary. So to get the one over here, I can do 180 minus 44 there. And that ends up giving me 136 degrees. So let's just work with the one we just drew out. So we've got a nice triangle in here. So if you can find the area of this triangle, it's going to be the same as the one over here. So this is 44 degrees. And these diagonals here, it says there that shorter one there is 8. So if I split in 2 there, this is going to be 4. And then this here is 14 in length. So splitting that one in half, that gives me 7. So let's find the area of that triangle. And again, we can use that. We've got side angle side here given, so we can use 1/2 AB sine C. So 1/2 times 7 times 4 times the sine of 44. Just make sure your mode there as you're doing this is in degrees. Times 7 times 4 times the sine of 44. And I'm getting 9.7 for now. And then I gotta find the area of the other triangle. So so this is angle 1, angle 2. So that's same as angle 2 here. So let's do 3 and 4 because they're going to be exactly the same. So if I drew that one out, this here is 7, this here is 4, and we found this out. They're supplementary, so this angle over here is 136. So same thing, 1/2 AB sine C. So 1/2 of 4 times 7 times the sine of 136. So 0.5 times 4 times 7 times the sine of 136. And I'm getting 9.7. So we've got our areas here. We've got 9.7. There's 4 of them. So, and they're all the same there. So 9.7 there times 4 gives me 38.8. So there we have the area of that. And just an interesting thing about this, the angle 1 and 4 there end up being exactly the same because remember we talk about in the unit circle here, if you've got this angle over here, which is, let's say this is 30 degrees here, and then it's reflected over here is 150. And both the 30 and the 150 there have exactly the same sine value each time. So that's no wonder that if we take the supplement of 44, which is 136 over in quadrant 2, of course it's going to give us the same value. And that will happen each time. So you really only need to find the area of one triangle and then multiply it by 4, because that will happen every single time when they're giving you the angle here in the center, where the diagonals there end up intersecting each other. Find the perimeter this time. So given that same information here, we've got that 44-degree angle. We said this is 136 because 44 and 136 there have to add to be 180. And then we've got our diagonal length there. So we've got an angle there, and then we split these up, and this was 4 and this was 7 over here. So if we could find some of our, if we could find those side lengths there, we'd be good to go. So I'm just going to ahead and use my law of cosines to find this. I'm going to call this x. So again, we got side, angle, side situation. So I'm going to use the law of cosines to find x there. So I'm going to say x squared equals, and I call these a and b, and or I should call it c since that's what we always use. C. So c squared equals a squared plus b squared minus 2ab cosine c. So 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 44. And then when you get your answer there, don't forget to go ahead and take the square root so you can plug that directly into your calculator there. I'm taking the square root of my answer there, and I'm getting about, C is about 4.97. So I've got this length there, so now I'm going to come over here and let's work with, we also need, here I'm putting red, this side length here as well. Let's call this one B this time. So this one over here is 4. So I can use my law of cosines again. This time I've got b squared equals a squared plus c squared minus 2ac cosine b. So I've got 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 136. Now notice this time we're using cosines, not sine. So plus 7 squared minus 2 times 4 times 7 times the cosine of 136. And then I got to remember to take the square root of my answer. And so B ends up being 10.26. So because we're using cosine this time instead of sine, when we use sine and we do the supplementary angle, we get the same value. With cosine, that's not true. All right, so I've got my values here. Perimeter, I got to add them all up. So I got a 4.97. I've got another 4.97 because this is also 4.97. This is 4.97. This is 10.26. And this is 10.26. So I'm going to put those all down. It's 10.26 plus 10.26 plus 9.7, 4.97 plus 4.97. And I'm getting 30.46 as my perimeter there. All right, we got one more here left to do, I believe. So now we got a parallelogram. Its sides are 7 and 12, and it has a 36-degree angle. What is the area and the length of the longest diagonal? So if this one here is 36, then the one up here has to be its supplement. So I have to take 180 there, minus 36, and I get 144. So this is 144 degrees. I'm going to draw it out again because I have to do the longest diagonal. So this is 144 degrees. This is my longest diagonal there. And this is 7 and this is 12. We're supposed to find the area and the length of the longest diagonal. So we can do that. We can use our trig area formula here, and we'll be able to find the area of this triangle over here, and then we can double it and get the area of this one. It's not drawn to scale, otherwise you'd see that triangle 1 and triangle 2 there are equivalent to each other, are congruent. So using our, I'm going to find the area of the triangle is equal to 1/2 AB sine of the angle. So 1/2 7 times 12 times the sine of 144. And I'm getting 24.69. And then area of triangle 2 is going to be the same thing. So what's the area of the parallelogram? Is equal to 24.69 times 2. And I'm getting 49.4. And then what's the longest length of the longest diagonal? Since I've got side, angle, side here, I can use my law of cosines. So I'm going to say c squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 144. And then I'm not going to forget to go ahead and take the square root of my value here when I'm done times the cosine of 144. So second, get my root, and then I got to find my answer. And I'm getting about 18.14, 18.1. So this is the length of the longest diagonal. And this is the area of my parallelogram at 49.4. So we have those. So your homework is to go ahead and work on that 3-5 worksheet. There should also be some information in your book if you need to look anything up. Or you can replay these videos. I'm putting them on Schoology for you under the notes. There'll be a link to it. So there they are.